Hello there, and welcome. I'm so glad you made it here. Maybe the day's been long and loud, and you're ready for something slower. Or maybe you're the kind of dreamer who drifts best when your mind has something vast to wander through, something that bends, folds, and stretches just beyond reach. Whatever brought you here tonight, this is your quiet space. There's nothing you need to do. Just let your breath fall into rhythm. Let the weight of the day slide off your shoulders. Because tonight, we're going to drift into the mystery of time, the invisible river that carries everything we know, yet never seems to move the same way twice. We'll slip between seconds and centuries, past clocks and gravity, and into the strange heart of relativity, where time runs faster on mountaintops and slower beside black holes. This isn't a lecture. It's a lullaby made of paradox. A slow unraveling of one of the universe's deepest illusions. So, close your eyes and listen gently. We're about to explore 100 mind-blowing truths about time and relativity, a journey through the moments that never really stand still. Time is not what you think. It feels so steady, so familiar, one second following another, each heartbeat marking your place in an invisible rhythm that never falters. We measure it, count it, divide it into hours and days and years, but all those tidy numbers hide something strange. What you call time isn't the same everywhere. It bends, it stretches, it listens to speed and gravity. The clock on your wrist and the one ticking on a satellite above you do not agree. They never have. For most of human history, we believed the universe shared a single heartbeat. The sun rose, the moon drifted, and we built our sense of order around their repetition. Even the word universe implied unity, one turning, one rhythm. But the deeper we looked, the more that rhythm fractured. When Albert Einstein began to play with the fabric of motion and light, he found something unsettling. There was no universal clock. Every observer, every traveler, every point in space carried its own personal timeline, moving neither faster nor slower until compared to another. What we once thought of as absolute time dissolved into something relative, flexible, and deeply personal. Imagine two friends watching lightning strike at both ends of a long train. To the person standing still on the platform, the flashes seem simultaneous, but to the one riding inside the moving train, the strike at the front appears first. They argue, both right, both wrong, neither able to claim the true order of events. Time itself has bent to their motion. There is no single truth about when things happen, only truths tied to where and how you move. That realization rippled through physics like a silent earthquake, reshaping everything built upon the old certainty. We think of seconds as identical, but they're not. A second on the surface of Earth does not match a second near the top of a mountain. The difference is microscopic, yet real. Gravity slows the passage of time, pulling on it as surely as it pulls on your feet. The stronger the gravity, the slower the clock. This means that the core of our planet experiences time at a slightly different pace than the sky above it. The nearer you are to something massive, the more time stretches and drags. Every moment you spend here is subtly different from the same moment lived somewhere else. Einstein called this woven tapestry of space and time the Spacetime continuum. He imagined the universe not as a stage where events happen, but as the fabric of the event itself. Space and time are threads of the same cloth, bending together under the influence of mass and motion. A planet doesn't pull on you through an invisible force. It curves the very stage you stand on, and you follow the bend. In that curved geometry, time no longer marches straight ahead. It leans, drifts, and slows. Every object, every traveler, carries its own version of how long things take. If you could race beside a beam of light, you'd discover something even more unsettling. The faster you move, the slower time moves for you. At near light speed, seconds stretch like soft rubber, and the rest of the universe seems to hurry past. A year might feel like an instant to you, while centuries pass elsewhere. This is not illusion or theory, it's measurable. astronauts on orbiting satellites return a few fractions of a second younger than those who remain on Earth. Their clocks, engineered to perfection, tick differently simply because they move differently through space-time. It's tempting to think of these effects as distant curiosities, things that only matter to physicists or astronauts, but you live within them every day. The GPS in your phone would fail in minutes if not corrected for the differences in how time flows at altitude and speed. Engineers must program satellites to account for relativity clocks, slowed by motion, sped up by weaker gravity, so that your device can tell you where you are. Without Einstein's equations, your map would wander, and your world would not quite line up with itself. The strange part is how easily our minds ignore this. We cling to the comfort of linear time, of mornings that follow nights, of birthdays that stack like pages in a book. But under that comfort lies a deeper truth. There is no universal order, no absolute present shared by all things. Each of us drifts within our own ribbon of space-time, moving forward but never quite alongside anyone else. When you look at someone standing across the room, even the light reaching your eyes is already old. You never see them as they are, only as they were a few nanoseconds ago. On cosmic scales, the difference becomes staggering. Light from distant galaxies began its journey long before Earth existed. The stars you see tonight might have burned out millions of years ago, yet their light is only now brushing your eyes. That light carries a record of ancient time, so when you gaze upward, you are looking through a tunnel of history. The present you live in is layered with ghosts of the past, and your own image travels outward the same way, forever receding into someone else's future. Einstein once said that the distinction between past, present, and future is only a stubborn illusion. The equation suggests that all moments coexist, stitched into the fabric of the universe like scenes on a quilt. You experience them one by one, but that may be a trick of perspective, a function of consciousness. To the universe itself, there is no flowing river of time, only a landscape of events spread out across 4 dimensions. You are not carried forward. You are already everywhere your life will ever touch. Your moments arranged like beads on a thread you can only move along in one direction. That idea unsettles something deep inside us. We want time to be alive, to carry meaning, to tell us who we are. And yet, when seen from outside, it becomes geometry. The story of your life is already written, and your experience is the act of reading it line by line. Some physicists call this the block universe, a reality where everything that has happened and will happen simply exists, eternally present. The feeling of time passing is just your consciousness moving along the line. But even if that's true, it doesn't rob time of wonder. It deepens it. It means that every moment, no matter how fleeting, is indelible. Every heartbeat, every breath, every sunrise is a coordinate fixed in the grand map of existence. The seconds you think you've lost still exist somewhere in that fabric, shimmering quietly, unreachable but real. Time is not what you think. It is not a ruler stretched evenly across the cosmos. It is elastic, local, personal. It folds under gravity and bends beneath motion. It connects every atom and star through the same subtle rhythm, yet never ticks the same way twice. You live suspended within it, swimming through a sea that has no surface and no shore. And somewhere, in a future already written, you may look back on this very moment, a second suspended in a universe that never truly lets anything slip away. We speak of time as if it were a river, flowing steadily forward, carrying us from birth to death, from memory to mystery. We talk about being swept along, caught in the current, running out of time. It feels natural, intuitive, even comforting. But what if it isn't true? What if time doesn't move at all? What if the flow you feel is only the motion of your own consciousness, drifting across something that never changes? The physicists who study spacetime say the river doesn't flow. It simply is. Imagine pressing pause on the universe, not just on motion, but on everything. every particle frozen exactly where it stands, every wave of light held mid-crest. The strange truth is that nothing would really stop, because in the deepest sense, nothing was moving to begin with. Time doesn't move. We do. The seconds and minutes we live inside are coordinates on a vast cosmic map, not beads sliding along a string. When you look at the universe this way, everything that has ever happened, is happening, or will happen already, exists laid out in full, like an intricate tapestry stretched across 4 dimensions. This is what physicists call the block universe. Past, present, and future are all part of the same unchanging structure. You could walk through it, if only you knew how, the way you might trace a finger along a photograph. The past isn't gone. It's simply located elsewhere in spacetime, sealed into the geometry of the cosmos. The future isn't waiting. It's already there, just out of reach. Every moment is fixed, each second a page written into the book of reality, and you, the reader, can only move forward, line by line. It's hard to accept, because we feel motion. In our bones, you sense the seconds slipping past, the years building weight behind you, the endless, invisible tide pushing you onward. But that feeling, as powerful as it is, may be a trick of perception. Your brain is not a clock, it's a storyteller. It stitches together snapshots of experience and smooths the seams until they seem continuous. You remember what was, anticipate what's next, and call that blend the present. Yet, the present is only the edge of your awareness moving across the static landscape of time. To understand this, think of film. A movie looks alive because light flickers fast enough to fool your eyes. Each frame is still, complete, silent, and unchanging. Only when your mind blends them does the illusion of motion appear. The same may be true of the universe itself. Each instant is a frame, timeless and perfect, and your consciousness is the projector, turning stillness into a story. You call that story your life. In the block universe, nothing truly begins or ends. The birth of a star, the fall of an empire, the final breath of a dying creature, all are frozen together in one eternal architecture. We perceive sequence because our consciousness moves, not because time does. The flow is inward, not outward. Somewhere, a younger version of you still laughs in a sunlit afternoon, and somewhere else, an older you sits beneath a different sky, remembering this very moment. Every version of you exists simultaneously, anchored to its coordinates, unaware of the others except through the echo of memory. It's a perspective both unsettling and strangely peaceful. If every moment exists forever, then nothing is ever truly lost. The people you've loved, the moments you thought had vanished, the seconds that slipped through your fingers, they still exist, suspended in the geometry of space-time, untouched by the illusion of flow. They are not gone. They are simply elsewhere on the map. When you recall them, you're not bringing the past to you, you're leaning toward a different part of the landscape, catching the faint glow of a place your mind once passed through. Einstein hinted at this comfort when he wrote to a grieving friend that the distinction between past, present, and future is only a stubborn illusion. He wasn't being poetic. He was describing the physics. The universe doesn't delete, it contains. Everything that has happened remains part of its structure, unrolled like a scroll that never ends. To move through it is to be aware, for an instant, of the frame your consciousness currently occupies. The flow of time is just the sequence of awareness, shifting from one frame to the next. Still, we live as though time moves, because it feels like it must. It's what gives shape to choice, meaning to memory, urgency to love. Without it, we would be trapped in a static eternity, unable to hope or grow or grieve. Maybe that's why the illusion is so perfect, because it's necessary. The story needs motion to be told. Even if the pages themselves never turn, the universe may be timeless, but we are not. We are the movement within its stillness, the dream of change woven into its unmoving fabric. So when you watch the seconds drift across a clock face, know that nothing is really drifting. The ticking hand is a marker, not a messenger. What you feel as passage is simply your awareness sliding forward through the infinite gallery of moments that already exist. Time doesn't flow, it waits. And within that waiting, you are the traveler, the heartbeat of stillness, the ripple across an ocean that never moves. A second feels absolute. It's the steady beat behind your pulse, the rhythm that keeps the world in sync. We build our lives on it: clocks, calendars, heartbeats, all marching to its quiet metronome. But in truth, a second isn't fixed. It stretches, softens, and shrinks depending on where you are and how fast you move. Time, for all its authority, is elastic. The universe lets it bend. Imagine you're floating far above Earth, looking down at the curved blue line of the horizon. The planet spins slowly beneath you, oceans glittering, clouds curling like breath. Up here, in the weightless quiet, your body drifts through weaker gravity. Down below, on the surface, gravity presses harder. Two identical clocks, one on the ground, one beside you, tick together at first. But after a while, their rhythm slips. The clock near Earth's gravity well slows ever so slightly, its seconds lengthening like taffy. When you return, the clock you left behind has aged a little less. This is not theory. It's measurable. In 1971, physicists placed atomic clocks so precise they lose only a second in millions of years aboard jet planes flying opposite directions around the world. When the planes landed, the clocks no longer agreed. They had diverged, tiny fractions of a second apart, just as Einstein predicted. Time itself had been altered by motion and gravity. Since then, we've repeated the experiment countless times, from mountaintops to orbit, and the results never change. Time flexes with the conditions around it. Up on the International Space Station, astronauts experience this difference every day. They orbit Earth at nearly 17,500 miles per hour, moving fast enough that relativity becomes noticeable. The speed slows their time slightly, but the weaker gravity at that altitude makes their time run faster. These two effects nearly cancel each other, but not perfectly. When astronauts return home, their clocks show they have aged a few milliseconds less than those who stayed behind. They've lived a slightly shorter slice of existence, tiny, but real. The principle behind it all is simple, though it feels anything but. Space and time are not separate things. They are two sides of one cosmic fabric, spacetime. And spacetime is not rigid. It bends in response to energy, mass, and motion. The more massive an object, the more it curves the space and time around it. You don't fall toward Earth because it pulls you. You fall because the ground beneath your feet sits in a valley of space-time, and you are following its curve. Time, too, follows that curve, slowing near massive bodies, speeding in the emptiness between stars. This means there is no single tempo to the universe. Time near a black hole drips slowly, like cold honey. Time between galaxies races almost freely. Even on Earth, the difference between mountaintop and sea level is measurable. People living in high-altitude cities experience time running faster than those at the shore by only nanoseconds, but still enough for physics to care. Your head ages faster than your feet. Your heartbeat unfolds across slightly different rates of time within the same body. It's strange to think of the seconds themselves stretching as if the universe were breathing. Yet that's exactly what it does. Each tick of every clock is a negotiation between motion, mass, and perspective. Time has no master tempo, no conductor keeping all instruments in line. Instead, it hums in countless rhythms at once, each observer carrying a private metronome that never quite matches another's. Einstein's insight reshaped more than physics. It changed the nature of reality. If time can stretch, then simultaneous loses meaning. Two events that seem perfectly synchronized to you may not align for someone else moving differently through the cosmos. There is no single now for everyone. There are only billions of overlapping nows, each slightly out of tune with the others, forming a grand, shimmering chord of existence. The implications ripple through every corner of life. The GPS satellites guiding your phone, circling Earth thousands of miles up, experience both weaker gravity and high velocity. Their internal clocks run faster than clocks on the ground, drifting by about 38 microseconds each day. Engineers must correct for that constantly, or your location would wander miles off course in minutes. The fact that your navigation works at all is proof that time is elastic, that your phone quietly accounts for the bending of space-time with every step you take. But beneath the equations, something deeper stirs. If time can stretch, what does that say about experience, about memory, about the strange way moments expand or contract inside us, how some hours pass in a blink and others feel endless? Maybe our perception mirrors the cosmos more closely than we realize. The universe stretches time under gravity. We stretch it under emotion. Both are forms of weight. The astronaut floating above Earth and the person watching from below will never agree perfectly on how long a moment lasts. But neither is wrong. Each exists in their own frame of reference, their own patch of the cosmic fabric. Time is not a single thread. It's a weave, pliable and alive. And through it, everything moves at its own pace, every heartbeat marking a rhythm slightly unique to its place in the grand design. The next time you glance at a clock and feel the seconds ticking steadily forward, remember that they're not as steady as they seem. Beneath the face of that clock, the universe is constantly adjusting, bending, compensating. The hand moves in compromise, not certainty. Somewhere high above, an astronaut floats through slightly slower time, watching the same sun rise and set while Earth spins below, each of you aging just a little differently, connected by an elastic thread that hums softly through the silence of space. Gravity is not what it seems. We think of it as a force, a pull from below, the quiet insistence that keeps our feet on the ground and the planets in their orbits. But that isn't how the universe sees it. Gravity is not a hand reaching up, it's a curve, a fold, a dip in the fabric of space-time itself. And within that curve, time begins to move differently. The stronger the gravity, the slower the seconds pass. The universe does not simply bend space, it bends the flow of existence itself. Picture a clock resting on the surface of Earth, its hands turning with quiet precision. Now imagine another clock far above it, high in the thin air of orbit, floating where Earth's pull has softened. To you, standing below, both appear to keep perfect time, but if you could compare them side by side, you'd find the one in orbit runs faster. Its seconds stretch lightly, freed from gravity's weight. Down on the surface, each moment is drawn out just a little longer, like a note held on a deep cello string. The stronger the gravity, the slower time's rhythm. The difference is tiny, barely measurable, but it is real, and it shapes the universe at every scale. This slow dance of gravity and time was one of Einstein's most radical insights. Before him, gravity was thought to be a simple attraction between masses, a tether, invisible but universal. Einstein replaced that tether with geometry. Massive objects, he said, don't pull, they bend. Planets and stars curve the fabric of space-time around them, and everything nearby follows those curves. A falling apple isn't being yanked toward Earth. It's following the shortest path through a warped landscape. The same bending that guides its fall also stretches time itself, because space and time are not separate, they are one connected stage, flexing and breathing together. Imagine standing near something unimaginably massive, a neutron star, a collapsed sun the size of a city, its gravity fierce enough to crush atoms. To an observer far away, your movements would appear to slow, your voice to stretch into deeper tones. Every heartbeat, every blink would take longer in their eyes, but to you, nothing would feel strange. Your seconds would seem normal. It's only in comparison that the distortion appears. as though the universe itself were watching you move through syrup. The deeper into gravities, well, you go, the more time resists you. At the edge of a black hole, this effect becomes absolute. A black hole's gravity is so intense that space-time curves in on itself. For anything hovering near that boundary, the event horizon time almost stops. To someone watching from a distance, you'd seem to freeze, your last moment stretched endlessly into stillness. Yet from your own perspective, you'd continue onward, unaware that your seconds have slowed beyond recovery. To the outside world, you have become a statue of light, trapped in the slowest waltz imaginable. Inside, you fall forever. This isn't a poetic exaggeration, it's how the universe truly behaves. Light, the fastest thing that exists, cannot escape the bend of a black hole's gravity. Even time becomes captive there. The very concept of before and after breaks apart. The dance stops being a rhythm and becomes a single, eternal pose. In that silence, physics loses its footing. Space and time trade roles, as if they've grown too tired to keep pretending they were separate all along. Yet, the same laws that govern that abyss also shape the gentlest corners of our world. Gravity's slow dance is happening everywhere under your feet, in your blood, between the atoms that make up the ground you stand on. Every mass, no matter how small, distorts space-time a little. Your body, too, has its own tiny gravitational field. It curves time infinitesimally, tugging the seconds inward, folding them ever so slightly toward you. You live surrounded by invisible distortions, 1,000 tiny ripples in the cosmic fabric, each adjusting the tempo of time just enough to matter. Our machines have learned to see this. The atomic clocks guiding the satellites above us tick differently depending on their altitude. They must constantly adjust, compensating for the slower rhythm near Earth's surface. If they didn't, the difference would quickly grow large enough to throw our navigation, the systems, into chaos. Without those corrections, your phone's map would drift, cities would slide, and reality would lose its coordinates. Gravity's influence on time is not abstract. It's a practical part of the machinery of modern life. Still, the deeper meaning of it all reaches far beyond technology. It suggests that time is not the steady river we believe it to be, but a fluid sea, rising and falling under unseen tides. Each planet, each star, each galaxy reshapes the tempo of the universe, a grand cosmic symphony in which every note plays at its own pace. The stronger the gravity, the slower the melody. The emptier the space, the quicker the tempo resumes. You are a participant in that symphony. The ground beneath you curves space-time. Your own weight bends it back. You move within those curves, never sensing their shape, yet entirely defined by them. Every second you live is a small act of resistance against gravity's slow pull, a quiet defiance of its rhythm. The universe is patient. It will slow everything eventually. But in the meantime, you move through it like a dancer, following music too vast to hear. Somewhere, near the heart of a black hole, time has almost stopped. Somewhere else, in the silent void between galaxies, it races nearly unbound. Between those extremes lies us creatures made of matter, bound to a planet that hums with gravity's soft lullaby. And as we live and breathe and dream, our seconds stretch and contract in the invisible choreography of space-time, each heartbeat a step in gravity's slow and endless dance. High on the mountain, the air thins. The world below fades into mist, and the hum of human life grows faint. Up here, the silence feels older, slower, like the mountain itself is holding its breath. But hidden within that quiet is something astonishing. Time itself is moving faster. Every heartbeat, every tick of a clock, every whisper of decay in an atom passes more quickly than it does down in the valley. You can't feel it, of course. But the difference is there, measured in billionths of a second, proof that even the rhythm of the universe changes with height. In 1976, Scientists sent an atomic clock aboard a rocket, carrying it far above the Earth's surface. When it returned, it was no longer synchronized with the identical clock left behind on the ground. Time had stretched, just a little. Higher up, where gravity's pull weakens, the grip of space-time loosens, and the seconds slip by more freely. The effect is minuscule, invisible to the senses, yet real enough to alter the way we navigate, communicate, and exist. On the mountain, you are living in a slightly different tempo than those below, your life unfolding just a breath ahead of theirs. Atomic clocks are the universe's most faithful timekeepers. Inside them, atoms vibrate with astonishing regularity, each oscillation marking the passage of time with precision so fine that no human-built mechanism comes close. They are the heartbeats of modern civilization, defining the length of a second so the entire world can agree on what now means. But when scientists placed one of these clocks on a high mountain and left another at sea level, they discovered those two nows were not the same. The mountain clock ran faster, its seconds stretched ever so slightly by the weaker pull of gravity. The lower clock, held tighter by Earth's mass, lagged behind. Gravity was not just bending space, it was bending time itself. This difference might seem poetic, but it's also practical, profoundly so. The satellites orbiting above us, circling Earth in quiet formation, each carry atomic clocks aboard. They live in a place where gravity's pull is weaker and speed's influence is stronger. Up there, their clocks tick faster than ours by about 38 microseconds every day. It doesn't sound like much, but if those differences weren't corrected, your GPS would fail almost instantly. The phone in your hand depends on those satellites to tell it where you are, measuring the time it takes for a signal to travel between sky and ground. If the timing were off by even a fraction of a millisecond, the system would place you miles away from your true position. So, engineers learned to compensate for relativity. Every satellite's clock is pre-adjusted before launch, deliberately slowed on Earth so that once in orbit, under weaker gravity, it keeps pace with the ground below. Each device in your pocket, every car navigating city streets, depends on that hidden correction. Without Einstein's equations whispering beneath the code, our entire digital world would drift into chaos. Every map would blur. Every signal would lose its anchor. Civilization itself would lose its sense of where and when it is. It's strange to realize that the mountain you climb to escape time's pressure actually lifts you into a different kind of time altogether. Up there, each second is a little longer, each moment passing just a fraction more quickly. You are aging imperceptibly faster than the people below, your atoms vibrating with a freedom their gravity slightly denies. If you could compare lifetimes between mountaintop and valley, the difference would accumulate, subtle but measurable. Time's fabric, stretched by altitude, reminds you that even stillness carries motion, even silence carries change. Every height in the world has its own tempo. The summit of Everest, the depths of the sea, the orbit of a satellite, all are different regions of the same woven continuum. Each place moves through space-time at its own pace, none more right than another. The mountain doesn't rush, the valley doesn't delay. They simply dance to different measures of the same cosmic song. You, too, are part of that rhythm, your every step changing the tempo of your existence by the smallest imaginable amount. The difference may be microscopic, but it connects you to something vast, the geometry of the universe itself. If you close your eyes on that mountain, you might imagine the Earth beneath you, curving space-time like a sheet bowed by weight. You can almost feel the slope of time as it climbs away from gravity's pull, seconds flowing more freely the farther you move from the planet's heart. It's not the mountain that rises, it's the flow of time that lightens. You are, in that moment, a traveler through gradients of being, living proof that the universe is not static but supple. And yet, the most extraordinary part is how ordinary it feels. You don't sense the shift in tempo. Your breath still moves in rhythm, Your pulse still marks the seconds as it always has. The elasticity of time hides beneath perception, invisible but absolute. The universe does not announce its miracles. It leaves them quietly embedded in the machinery of reality, waiting for those who listen closely enough to hear. Down below, in the valley, time drags slightly slower. Up here, above the clouds, it runs a little faster. Between those two worlds, an endless exchange continues, gravity and altitude tugging gently at the threads of existence. And whether you know it or not, you live within that tension. Every heartbeat, every footstep, every glance toward the horizon carries you through time's shifting landscape. The clocks on the mountain and the clocks in the valley never quite agree, yet together they compose the harmony of the cosmos. A universe where even time itself climbs and falls endlessly, with the shape of the earth beneath your feet. There are two siblings, born beneath the same sky, breathing the same air, their lives beginning side by side. For years, they grow together, their days synced in rhythm, shared laughter, mirrored milestones, the easy symmetry of time passing equally for both. But one of them dreams differently. They want to see what lies beyond the horizon, to touch the edge of the possible. One day, that dream becomes real. A spacecraft, gleaming and patient, waits to leave Earth behind. The other stays home, watching from the ground as the countdown begins. In that moment, their timelines start to part. The journey is not just distance, it's velocity. As the ship accelerates, climbing past the atmosphere into the black, time begins to warp. At first, the difference is microscopic, buried deep inside equations. But as speed increases, edging closer to the speed of light, time itself begins to stretch. For the traveler inside, the seconds flow normally, each heartbeat steady, each breath familiar. The view outside, though, starts to melt. Stars blur into pale streams. Space folds around the vessel, and the journey stretches on. To the traveler, months pass. To the one left behind, years begin to unfurl. From Earth, the stationary sibling watches seasons turn. The world spins through countless sunrises. Decades might pass before the ship returns. To those watching, the traveler's voyage appears impossibly long, an odyssey that could outlast a lifetime. But inside the craft, time moves differently. The engines hum, the clocks tick slower. What feels like a few short years in motion is, from the perspective of the planet below, an entire generation gone by. The two siblings are now divided not by distance, but by the shape of time itself. This is the twin paradox, a simple thought experiment that captures one of Einstein's strangest truths. When one twin travels near the speed of light and returns, they will have aged less than the twin who stayed behind. Time for the traveler has dilated, stretched out under the pressure of speed. The faster you move, the more space-time bends around you, and the slower your personal clock runs compared to the universe's. The paradox isn't really a contradiction, it's a revelation. Motion through space and motion through time are two halves of the same coin. The faster you move through one, the slower you move through the other. Imagine their reunion. The ship descends through the sky, streaking with plasma as it cuts back into the atmosphere. The traveler steps out, expecting to see the same familiar face that waved goodbye. But the one waiting at the landing site is older hair, silvered, skin marked with time. Decades of Earth's gravity have passed, while only a handful of years have brushed the traveler's life. They embrace. But it's like touching a reflection separated by eras. For one, the past was a long memory. For the other, it was yesterday. To both, it feels impossible. How can the same heartbeat, the same mind, have lived through two different lengths of history? Yet this is how the universe keeps its balance. Each twin followed their own path through space-time, and the geometry of those paths is what determines how much time each has truly lived. The traveler's route bent deeply into the dimension of space, cutting across vast distances, while the one on Earth followed a simpler, straighter path. Their clocks diverged not through malfunction, but through the very shape of reality. The paradox has been tested, not with people, but with machines. Atomic clocks placed on jets and satellites return slightly younger than those left on the ground. Muons, particles created in the upper atmosphere, live longer when moving at near light speeds than when standing still. Time dilation isn't theory anymore, it's a measurement, a fact etched into the machinery of the cosmos. It tells us that there is no universal time, no single clock that governs all. Every traveler carries their own. The thought lingers, though. What does it mean for memory, for love, for connection, when time itself can divide two lives? The twin who stayed has lived entire seasons of change, watched friends grow old, felt years stack upon years. The traveler has crossed galaxies of distance, but carries only a few years' worth of experience. They have outpaced age, escaped decay for a power while, but at the cost of synchronicity. They left as equals and returned as a living echo from a slower universe. There's something haunting in that. Not tragedy exactly, but awe. It means that time is not a single thread winding evenly through every life. It's a web, elastic and uneven, stretching differently depending on how we move through it. Two hearts can beat together and still drift apart through the folds of space-time. The universe doesn't promise fairness, it promises consistency. The equations never lie, even when they feel like heartbreak. And yet, maybe there's beauty in that difference. The traveler has seen stars frozen in their light, galaxies distorted by motion. They've lived a few short years that contained entire cosmic vistas. The one who stayed has lived the slow, steady unfolding of ordinary time, the small miracles that only patience reveals. When they meet again, each has carried a different kind of infinity. In the end, their reunion is not about loss, but perspective. They are proof that time is not a single current flowing through everything. It is a field, bent and reshaped by motion, molded by gravity, altered by the paths we choose. The universe does not keep equal time, it keeps true time, written in the geometry of every journey. The siblings embrace, one aged by years, one by wonder, both bound by the same truth. Time is not universal, it's personal. It stretches, folds, and dances, holding each of us in a rhythm only we can feel. There is a limit woven into the universe, a boundary that no matter, no message, no dream can ever cross. It is not a wall or a force, but a rule written into the geometry of existence itself. The speed of light, 186,000 miles per second, is not just fast. It is final. Nothing with mass can reach it, and nothing beyond it can return. It is the pulse by which the cosmos keeps time, the measure against which all motion, energy, and cause are compared. Light doesn't simply move. Through space, it defines what space and time are allowed to be. For centuries, people believed speed had no ceiling. Push hard enough, and you could go faster, add more energy, and you'd close the gap. But Einstein showed us the cruel symmetry of reality. The closer you approach light speed, the heavier you become. The universe resists you, folding time and space in protest. Each burst of energy you pour into acceleration becomes more than motion. It becomes mass, and the faster you move, the more impossible further movement becomes. To reach the speed of light, you'd need infinite energy, and infinity, the universe insists, is not available to rent. To a photon, a particle of light, time doesn't exist. For it, every journey from the heart of a distant star to your eye is instantaneous. The light that left a galaxy 10 billion years ago arrives to you now in what, from its own perspective, was no time at all. It doesn't experience distance the way we do, or duration, or waiting. It simply is. That's the strange truth about the universe's speed limit. The fastest possible motion isn't movement at all. It's timelessness. The limit is not about how far you can go. It's about how time itself reacts when you try. The connection between speed and time is intimate. As you move faster, time slows for you. The more you strain toward light speed, the more your clock stretches, your seconds elongating like elastic bands. To those watching from outside, your journey appears frozen in slow motion. To you, everything beyond your window races past, galaxies blurring, moments collapsing. Motion through space steals motion through time. You can trade one for the other, but you can never have both in full. Light takes this trade to its extreme. It moves through space completely and through time not at all. That relationship between speed, time, and energy keeps the universe coherent. It's what protects cause and effect. If you could travel faster than light, you could send a message into the past. An action could arrive before its cause, and reality itself would unravel. A universe without this limit would have no consistency, no logic, no arrow of time. It would be chaos disguised as possibility. The speed of light is more than a number. It's the stitching that keeps time from tearing. Even so, light's limit is not a boundary of despair. It's a revelation of balance. The universe is not built to deny you. It's built to protect its own harmony. Within that constraint lies everything we know: stars burning, planets orbiting, life thinking, all of it orchestrated under the same invisible tempo. Photons obey it. Gravity respects it. Even the expansion of space itself dances around it. The cosmos plays in perfect rhythm, and the speed of light is its metronome. You can see its influence everywhere, even in the color of the sky. Sunlight scattered through the atmosphere slows just enough to paint the air blue. In distant galaxies, the light that leaves ancient stars stretches as the universe expands, reddening with the distance, each wave carrying the fingerprint of time's growth. The very fabric of space records motion in color, as if light were both brush and canvas for the portrait of reality. And yet, the human heart still wonders what it would be like to break that rule, to move faster than light, to leap across time like skipping stones over water. Science says it cannot be done, but imagination ignores the word cannot. It dreams of warp drives, wormholes, shortcuts through the folds of space-time. Maybe one day we'll learn to curve the path itself, to step between moments rather than racing through them. But even if we never do, the dream is part of the same law. Every curiosity, every reaching thought is bounded by light's patient edge. If you could somehow watch the universe from outside, from a place untouched by its speed limit, you'd see everything happening at once. Every sunrise, every supernova, every quiet breath unfolding together. The boundary that slows us is also what allows that grand simultaneity to exist. It's not a barrier meant to frustrate us. It's the structure that gives meaning to motion, that allows a before and after, that lets existence tell a story instead of dissolving into static. Every beam of light that reaches your eyes is a message delivered at the fastest possible speed. It carries the memory of stars long gone, the echo of fires that burned before Earth existed. Each photon is a time traveler that never aged, a witness to the entire history of space. And when you look up at the night sky, you're not watching the universe as it is, but as it was, an ancient light show playing on the edge of an unbreakable rule. Nothing can outrun light, but within that limit, everything becomes possible. Time stretches, energy transforms, matter dances with motion. The universe holds together because of that single constant, that quiet, unwavering speed that threads through everything. It's the heartbeat of creation, steady and eternal, whispering across the dark. This far, and no farther, and within that boundary, infinity unfolds. When you look at the night sky, you aren't looking into space, you're looking into time. The light that reaches you from those distant stars has traveled for thousands, sometimes millions, sometimes billions of years to arrive. Each photon is an ancient messenger, carrying with it the story of where it came from and when. That soft shimmer you see above your head isn't the universe as it is, it's the universe as it was. The stars are memories, their glow a whisper from the past that still hasn't faded. Take a single beam of light. It leaves the surface of a distant star, streaming through the dark with no engine, no sound, no rest. It crosses the vacuum at the same steady speed it always has, immune to time as we understand it. Through dust clouds, through gravitational fields, through the slow expansion of the universe itself, it travels. By the time it brushes your eye, it may have been moving for longer than your species has existed. You are seeing a moment that ended long ago, and yet, for you, it's happening right now. The universe shows you its history every time you look up. Our nearest stellar neighbor, Proxima Centauri, lies 4 light-years away. That means the light you see from it tonight left 4 years ago, before some of your current thoughts, before certain memories existed. A star further away, say one in the Andromeda galaxy, sends you light that departed when early humans were still learning to spark fire. Peer deeper, through the lenses of telescopes like Hubble or Webb, and you reach light that has been traveling since the dawn of galaxies themselves. Those faint, red-shifted smudges of color are not present-day objects. They are fossils of illumination, frozen in transit, still moving toward us across cosmic distances too vast for imagination to contain. It's an odd kind of intimacy to see something so ancient in real time. The sky above your head is a layered record, a library of light written over billions of years. Every glance upward reads a page of history. There is no now in the stars, only a cascade of thens, arranged by distance. The nearer the source, the more recent the story. The farther, the older the memory. The universe is always revealing itself, but always late, its messages arriving on a delay no one can shorten. If you could somehow travel fast enough to chase a beam of light, you would never catch it. From your perspective, it would always stay ahead, always a little beyond reach. For light, time does not flow. It simply exists. The moment it leaves its source and the moment it arrives are one and the same to the photon itself. What feels to us like an unimaginable journey across eons is, to the light, no journey at all. It does not age. It does not change. It only moves endlessly until it is caught by something, a planet, an eye, a camera, and then, at last, it tells its story. The oldest light we can see is the cosmic microwave background, a faint afterglow from nearly 14 billion years ago. It's the leftover radiation from the birth of the universe, stretched and cooled by time until it hums softly across all of space. That glow is the first light to escape the dense fog that once filled everything. When you detect it, you are looking at the universe as a newborn, still wrapped in heat and expansion. Its first moments preserved like a photograph taken before memory began. We live surrounded by that light. It passes through us every second, the echo of creation itself. Even the sun, the nearest star to us, participates in this delay. The light that warms your skin left its surface about 8 minutes ago. When you lift your face to it, you are feeling warmth from the recent past, a faint temporal echo of the star's constant fire. The sunlight on your hand right now began its journey before the moment you decided to stand there. Every ray, every shadow, is a conversation between what was and what is. It's humbling to realize how thoroughly the universe withholds its present from us. We never see anything as it truly is, only as it was. The galaxies spinning in distant clusters might already be gone. The stars painting tonight's constellations could have burned out centuries ago. What you see is their farewell, a light still in flight, unaware its source has vanished. The sky is a ghost show, and we are the last audience. And yet, there's something beautiful in that distance, something profoundly human in our ability to translate delay into meaning. We build telescopes, collect photons, and use them to reconstruct the story of everything. We turn ancient light into knowledge, into wonder, into understanding. We are creatures bound to the present, but our eyes make us time travelers, Every glance upward is an act of communion with the past. Every night sky, a reminder that history is still arriving. Perhaps that's why the stars feel so alive, even though they are mostly silent. They are not just pinpricks of light, they are living records, fragments of existence still journeying toward recognition. To look at them is to participate in an ongoing exchange across billions of years. You are not watching distant objects. You are meeting their ghosts, hearing their last words spoken in light. The night sky is not a picture of the universe. It is its memory. Every shimmer above you is a postcard from the past, traveling at the one speed that defines reality. You, standing there, eyes wide in the dark, are part of that same equation, a moment in someone else's future whose light has not yet begun its journey. The word now feels simple. You say it without thinking, as if it points to something solid, a single shared moment everyone can agree upon. You imagine the universe breathing with you, clocks everywhere striking together in a grand synchronized rhythm. But it doesn't. There is no universal now. The present, as real as it feels, is a local illusion, a bubble of perception that drifts differently for everyone, everywhere. What's happening to you in this instant could already be ancient history to someone far away, and what's unfolding in their now may not yet exist in yours. The cosmos does not keep time as one. It is a patchwork of moments, stitched together loosely by the speed of light. Einstein showed us that simultaneity, two events happening at the same time, is not absolute. It depends on where you are and how you're moving. Imagine two lightning bolts striking opposite ends of a long train. To a person standing on the platform, they appear to flash at the same instant. But to someone riding inside the train, racing toward one flash and away from the other, the strikes no longer seem simultaneous. One arrives before the other, and both observers are correct. The difference isn't in the lightning, it's in the nature of time itself. There is no shared stage on which all events unfold together. The universe's clocks refuse to align. Our brains aren't built to sense this. They crave a single timeline, something steady to build stories upon. To us, now feels infinite, stretching across continents and stars. You can look at the moon and imagine it happening with you, your heartbeat, its glow, both existing in the same instant. But that moonlight left over a second ago. What you see is a ghost of the past, already finished, already fading. The farther you look, the older the present becomes. Every star in the sky is delayed. The entire cosmos is a gallery of expired moments, still shimmering with borrowed light. This difference is small here on Earth. Nanoseconds between mountaintops and valleys, between fast planes and still ground, but across the universe, it stretches into eternity. For a galaxy a billion light years away, our now won't reach it for another billion years. We live inside a sphere of information bounded by light's speed. Nothing can update faster than that. Every new photon that reaches us is the edge of our knowledge, the bleeding frontier between the universe as it was and the universe as it is. The present is not a slice of time. It's a moving surface, expanding outward at light speed. When astronomers point telescopes at the farthest reaches of the cosmos, they're not just seeing back in time, they're peering across millions of different nows. Each speck of light comes from a separate era, its own slice of cosmic history. Some galaxies we observe as infants have long since grown old or vanished altogether. Others, whose light hasn't yet reached us, are still invisible, their existence future to our perspective. The universe we see is never the universe as it is. It's a mosaic of disjointed times, layered and incomplete, like a photograph still developing at the edges. If you could travel faster than light, you might imagine catching up to another region's present. But even that wouldn't unify time. You'd only be exchanging one local now for another, trading one version of reality for a slightly different one. The universe doesn't offer a master clock. Every observer carries their own, each moving rhythm shaped by speed, gravity, and perspective. There is no single pulse beneath it all, only a chorus of ticking hearts, none quite in sync. It's easy to forget this when you speak about events far away. You say a star is exploding right now, or a planet is circling its sun this instant. But those words are shortcuts, human conveniences that disguise the truth. We cannot know what's happening right now anywhere but here. The present is a secret the universe keeps carefully local. By the time its news reaches you, it's already ancient. The cosmos doesn't share a single unfolding. It's an infinite number of separate unfoldings, drifting apart with every beat of time. Still, there's something quietly comforting in that thought. The idea that the universe holds all of its moments at once, that your past and future, and everyone else's, coexist somewhere, each woven into the same vast fabric. Every now, from every point of view, is real to the one who inhabits it. The boundary between past and present isn't a line, it's a relationship. When you look at a star, you are not just witnessing history. You are participating in the moment it once called now, bridging the gap with your gaze. Perhaps there's no universal present, because the universe is too generous for one. It gives every place, every being, its own timeline, its own version of now, and lets them all exist together without hierarchy or center. The illusion of simultaneity, the feeling that everything is unfolding side by side, may be the universe's kindest lie. It allows us to feel connected across impossible distances, to believe in shared moments even when the cosmos denies them. So when you stand beneath the stars, remember, you are surrounded by millions of different nows, some from the near past, some from before Earth existed, all shimmering together in one impossible view. You are not living in the present. You are standing in the middle of time's great ocean, where every wave is a different moment, and every glimmer of light is proof that the universe never had just one. Now it has all of them, forever. If you drop a glass, it shatters. Pieces scatter across the floor, sharp edges catching the light. You could gather them up, glue them carefully, try to make it whole again, but it will never be the same. The cracks remember what happened. The air remembers too, the sound still echoing somewhere. The universe keeps the record. That is the nature of time. It moves forward, never back. The arrow points one way, and it's carved not by clocks or calendars, but by entropy, the quiet drift from order to disorder that underlies everything. Entropy is the measure of how many ways something can exist. A tidy room has few possibilities, a messy one countless more. Left alone, things move from structure to chaos, not out of malice or decay, but because there are simply more ways to be messy than neat. A glass on a shelf is one fragile arrangement of atoms. A shattered one is billions. The universe favors variety. That preference gives time its flow. When order dissolves, the future becomes distinct from the past, and there's no path back that doesn't defy probability itself. At the smallest scales, the laws of physics are reversible. The equations don't care which direction time runs. A collision between particles looks the same played backward, but the world you live in doesn't. Heat flows from warm to cold, not the other way around. Smoke disperses into air, never recoalesces into a cigarette. A wave breaks on the shore and doesn't reassemble from foam. Somewhere between the clean mathematics of the microscopic and the messy theater of reality, something irreversible happens. Entropy accumulates, and with it, time begins to march. The early universe was impossibly ordered, a dense, uniform sea of energy, smooth and simple. That simplicity held within it the potential for everything. Over billions of years, it unraveled into complexity. Galaxies, stars, planets, and the delicate chaos of life. Each moment since has been an expansion of possibilities, an unfolding of arrangements too vast to count. From that low entropy beginning, the arrow of time was born. We are living inside its gradient, flowing toward a future where order becomes ever more unlikely. You feel this arrow everywhere, though you rarely notice it. You see it in the way ice melts, in the way memory works. You can remember the past because traces of it remain, imprinted in matter and mind. But the future leaves no such marks. It's blank, open, waiting to be written by the spread of entropy. Your own body obeys the same rule. Energy flows through you, food burning into warmth, structure giving way to disorder, one heartbeat at a time. Life is a local reversal, a brief pocket of order carved from chaos, but it sustains itself only by creating more entropy elsewhere. Even your thoughts, fleeting as they are, depend on energy flowing irreversibly through your brain. The arrow of time isn't something the universe imposes on you. It's something you create just by existing within it. Every movement, every transformation increases the disorder slightly. When you exhale, you release heat that can never fully return. When you light a candle, its flame transforms wax and air into new forms, spreading energy outward, never inward again. You are part of the great dissipation, a participant in the unfolding randomness that defines forward motion. Scientists still wonder why the universe began in such a low entropy state. Why start from order at all, when disorder is the natural end? Some think it's simply the only way time could begin. If the cosmos were born already in chaos, nothing would change, and change is what creates experience. Time, at its core, is a record of transformation, a memory written in the increasing number of ways the universe can arrange itself. We move forward because that record cannot be erased. There's a strange beauty in this inevitability. Entropy means decay, but it also means creation. Stars die, scattering the elements that form new worlds. Broken systems give rise to new patterns, new complexity. Even destruction feeds the flow of change. The arrow of time is not cruel, it's creative. It writes history in fragments, each one irreversible, each one essential. When you look around, you can sense the quiet tug of that forward motion. Dust gathers on untouched surfaces, mountains crumble, rivers carve new paths. Even in stillness, things shift. The arrow is always there, unseen but absolute, carrying you with it. You cannot stand outside it. You can only move through it, a conscious ripple in an endless current. And yet, though entropy ensures that nothing lasts forever, it also ensures that nothing is wasted. Every fragment of broken glass, every faded photograph, every last whisper of heat becomes part of the larger story, the grand diffusion of energy that defines the universe's existence. Time's arrow moves forward not as a thief, but as a sculptor, shaping impermanence into meaning. So when you think about the past, understand that it isn't gone. It's transformed, distributed, woven into the fabric of what is now. The future, too, is not yet real. It waits on the far side of entropy, waiting for the next rearrangement of what's left behind. Between them lies this moment, fragile and fleeting, balanced on the slope of disorder. You are part of that slope, part of the arrow's direction, a temporary spark in the slow and beautiful unmaking of the universe. Before there was time, there was no before. No ticking clocks, no unfolding moments, no sequence of cause and effect. There was not even darkness, because darkness requires space to hide in, and space did not yet exist. The beginning of time is one of the most profound and puzzling ideas the human mind can confront. The notion that everything matter, energy, motion, distance, even the idea of then, once fit into something smaller than a grain of sand. The universe began not in space, but as space. It wasn't an explosion in the void. It was the void itself waking up. Physicists call that awakening the Big Bang, though the name is misleading. There was no bang, no center, no edge. Everywhere expanded at once. Every point became a horizon stretching away from every other point. In the first instant, less than a trillionth of a second, time began to tick. The newborn universe inflated violently, faster than light itself. not because something traveled through space, but because space itself was stretching. Out of that expansion came everything that would ever be: the galaxies, the stars, the atoms, and eventually the consciousness now trying to imagine its own beginning. What does it mean to say that time began? We can't help but imagine something before it, something waiting for the clock to start. But before is a concept that requires time to exist, and time didn't yet. Asking what happened before the Big Bang is like asking what lies north of the North Pole. The question folds in on itself. To the laws of physics as we know them, time is not an endless line extending backward. It has a boundary, a horizon beyond which the word when no longer applies. Still, our minds resist the idea of a beginning without a cause. We want a before, a source, a spark. Maybe time itself is cyclical. Some suggest a cosmic loop in which each universe gives birth to the next. Maybe there was a previous universe that collapsed inward, compressing into a singularity, only to bloom again as ours. In that vision, time never truly starts or ends. It breathes. The Big Bang is not creation from nothing, but transformation, an eternal heartbeat expanding and contracting across eons. Others imagine that time as we know it is just one thread in a larger fabric, that before the Big Bang there existed a kind of timeless potential, a quantum haze where reality and possibility were still indistinguishable. Whatever came first, it was strange beyond comprehension. In those earliest fractions of a second, the universe was an ocean of energy so dense that matter could not yet exist. Particles burst into being and vanished again, constantly trading places with pure energy. Space rippled like a living thing. Time itself may have flowed differently, slower, thicker, less defined. To speak of seconds, then, is to borrow a human measure for something that had not yet stabilized. The cosmos was learning how to keep time. As it cooled, symmetry broke. Forces that had once been unified: gravity, electromagnetism, the nuclear forces separated, carving structure from chaos. With that separation, time gained its direction. The arrow began to point forward, driven by entropy, by the simple tendency for order to unravel into complexity. It was the first irreversible thing to happen, and it gave the universe a memory. From that point onward, change became possible, and with change came history. Time, once an abstract dimension, became a stage for everything that would ever unfold. Even now, the universe carries the imprint of that beginning. The faint microwave afterglow that fills all of space is the cooled remnant of its birth, a whisper from when time itself was only a few 100,000 years old. That glow is the oldest light we can see, the edge of the observable past. Beyond it lies the opaque wall of the first moments, where our equations falter and imagination must take over. What lies beyond that horizon, if anything remains unknown? It may be that beyond is meaningless there, a direction that no longer exists. And yet, despite that mystery, time continues. Each second that passes is a direct descendant of that first instant, stretched and softened by the universe's expansion. The same laws that shape the cosmos then still shape you now. The atoms in your body trace their ancestry to that moment when energy became matter, when the first flicker of duration began to unfurl. You are a ripple in the wake of the universe's birth, living inside the story that time has been telling ever since it learned to move forward. Sometimes, late at night, when you stare into the sky and see the faint glow of starlight reaching across millions of years, you are peering back toward that beginning. You are watching echoes of the first sunrise that ever was, a light that began its journey before there were eyes to see it. And in that gaze lies a paradox, the awareness of time looking back upon its own creation. The universe became conscious of itself through you, through this fleeting moment of curiosity. Perhaps that's the most extraordinary part of the story, that the birth of time wasn't just the beginning of everything external, but also the seed of awareness, the potential for wonder. Time began, and with it came the possibility of remembering, imagining, and asking questions that stretch beyond comprehension. Maybe the question of what came before will never be answered. Maybe it doesn't need to be. It is enough to know that from nothing or something like it, the universe awoke, exhaled, and began to count the seconds. And from that first pulse onward, everything that ever was or will be began to unfold in rhythm with the heartbeat of time itself. At the heart of a black hole, time loses its meaning. The familiar rhythm of seconds and minutes collapses, stretched thin until it stops altogether. A black hole isn't just a place of immense gravity. It's a distortion of reality so deep that even the idea of before and after begins to unravel. To stand near one, if you somehow could, would be to witness time itself pulled toward stillness, its flow caught in a web of infinite gravity. To look closer is to see the edge of comprehension itself. A black hole begins as a star that has died too heavily. When the fuel that feeds its fusion burns out, gravity wins. The star implodes, folding inward, shrinking smaller and denser until the mass of millions of suns fits into a sphere no larger than a city. At that point, the escape velocity, the speed needed to outrun gravity, exceeds the speed of light. And since nothing can move faster than light, nothing can escape. Not matter, not energy, not even time. From the outside, the black hole is wrapped in an invisible border called the event horizon. It's the surface of no return, the boundary where space-time bends so steeply that every path inward leads inevitably deeper. To approach it is to fall toward a point that isn't really a point at all, a singularity, a place where the equations break, where curvature becomes infinite and our understanding fails. The closer you get, the slower your time runs compared to the world beyond. Each second for you becomes longer, heavier, stretched by gravity's pull. If you were to hover just above the event horizon, with some impossible propulsion keeping you there, you would experience time flowing normally. Your heartbeat, your breath, your thoughts, all would feel the same. But if someone were watching you from a safe distance, they would see something very different. To them, your motion would slow, your voice would deepen and fade, your image would dim and redden as light lost energy climbing out of the gravitational well. As you drift closer, you would appear to freeze, suspended on the brink forever, never quite crossing the line. From the outside, you would seem trapped in an eternal moment, and yet, from your own perspective, you would cross the horizon in an instant. Time would continue smoothly. There would be no sudden flash, no warning, no sense of entering a forbidden place. You'd simply fall, and the universe outside would accelerate away from you. Stars would streak and warp, the cosmos collapsing into a shrinking circle of light above. Beyond the horizon, all directions would point inward. Down would lose meaning. The singularity would no longer be a distant center, it would be your future. Inside, space and time exchange roles. The singularity is not just a place in space. It is a moment in time, one that lies ahead of you, the way tomorrow does now. You cannot turn away from it any more than you can refuse to move forward in your own life. Every path, every possibility, leads to that end. It's not that you fall toward the singularity, it's that you're carried to it by the very nature of time itself. Inside the horizon, falling is not movement through space, it is the passing of time. To an outside observer, you never vanish. They see you frozen at the edge, your light fading until it's too faint to detect. In their universe, you are eternal, still hovering on the border. But in your universe, you are long gone, already past the point of no return, drawn into the deep interior where time curves inward on itself. Both views are true. The paradox isn't a flaw, it's a feature of spacetime's design. What is eternal to one perspective is fleeting to another. No one knows what happens at the singularity. The mathematics we trust everywhere else dissolves there. Gravity crushes matter into densities beyond imagination. Space becomes so curved that distance loses meaning, and time so warped that its flow may cease entirely. Some theories suggest that the core is not an end, but a doorway, that the collapsing matter could re-emerge elsewhere, perhaps birthing another universe. Others believe that whatever enters simply ceases to exist in any form we can describe, erased not in fire but in geometry. The truth lies hidden behind that veil, guarded by physics itself. Still, black holes are not just destroyers, they are archivists of time. Every particle, every photon that crosses the horizon adds to their mass, their spin, their subtle electric whisper. They record the universe's history in the only language that matters, gravity. Even the information of what falls in may not be lost, only rewritten, encoded on the surface like ripples in space-time's skin. In that sense, black holes are cosmic mirrors, places where time, memory, and matter converge into something that neither moves nor dies. To stand at the edge of one would be to look at the universe's deepest truth, that time is not constant, not absolute, not guaranteed. It can slow to a crawl, stretch toward infinity, or vanish altogether. The clock you carry, the one that beats softly inside your chest, is only a local rhythm, a tiny pulse compared to the immense curvature that shapes the cosmos. Near a black hole, that rhythm falters, time itself begins to slip. And yet, even as it breaks, there is beauty there. The frozen moment on the horizon, the stretched seconds spiraling into silence. They remind us that time is not a river, but a fabric, woven tightly until gravity pulls at its threads. Somewhere out there, near the edge of a black hole, the last light of a falling star is still hanging in place, never quite fading, suspended forever between motion and stillness. From our perspective, it is frozen. From its own, it has already fallen. Both truths exist together, written into the same silent, endless curve of space-time. Imagine a universe utterly still, no stars flickering, no atoms vibrating, no light moving through space, every particle fixed, every field frozen. Would time still exist there, or would it vanish with the silence? It's a question that seems simple until you try to feel it, to imagine what nothing happening really means, because the moment you really picture it, you've already betrayed the idea. You've made it into an image, an instant that follows another. You've created a before and after. You've brought time back into the room. Our experience of time is inseparable from change. We measure it by motion, the swing of a pendulum, the orbit of a planet, the beating of a heart. The passing of seconds only makes sense because something moves between them. Without motion, how would you know a moment had passed? If everything in the universe paused together, not just the stars, but your thoughts, your neurons, your awareness itself, could that pause even be noticed? The question begins to fold in on itself, a loop of logic that circles the same void it tries to define. Physicists and philosophers have wrestled with this paradox for centuries. In classical physics, time is treated as a background, a vast, invisible grid that continues no matter what happens within it. Even if every atom froze, the cosmic clock would keep ticking, indifferent and eternal. But relativity shattered that idea. Time is not a separate stage. It's woven into the fabric of space, stretched and curved by energy, altered by motion. Without events, without movement or interaction, there is no space-time to measure. Time, in Einstein's view, is not something that flows through the universe. It is something the universe does. But if time depends on change, what about the smallest scales, where quantum mechanics reigns? There, the universe never truly stands still. Even in a perfect vacuum, particles flicker in and out of existence, borrowing energy from uncertainty itself. The void hums with restless possibility. In that sense, total stillness may be impossible. Time persists because change cannot be eliminated. It's baked into the nature of reality. Every fluctuation, every ripple of probability, keeps the clock from stopping completely. Still, the human mind keeps asking, Could there be a frozen moment, a true standstill where nothing at all occurs? Suppose you could somehow pause everything, the expansion of the universe, the spin of every electron, the whisper of every photon, and step outside it to observe. You might look upon that unmoving universe and see beauty in its silence, a sculpture made of existence itself. But even to observe it would be to compare it to something else, to a memory of motion. The act of noticing would create time again, because perception is change. Awareness depends on difference, the brain comparing what was to what is. Without that difference, consciousness has no ground to stand on. Some thinkers suggest that time is not real at all, that it's only a construct emerging from the way we experience change. In this view, the universe is a static block, an eternal structure where all moments coexist. Nothing happens inside it. What we call time is simply the path our minds trace through that structure, a kind of narrative stitched from our perception of cause and effect. The world doesn't move, we move through the world's timeline, like a flashlight beam scanning across a mural that's already finished. From that perspective, a universe without change doesn't lose time. It contains all of it at once. And yet, even that feels unsatisfying, because we live inside time's current. We feel it pressing against us, slipping past us, defining us. Our bodies age, our memories accumulate, our choices become irreversible. Change isn't something added to time, it is time. To remove one is to erase the other. A frozen cosmos may exist as an idea, but it cannot exist as a reality, because existence itself is motion. To be is to transform. When you think about moments, it's tempting to imagine them like frames in a film, discrete, separate, each one complete on its own. But a frame without the one before and after it means nothing. It's the sequence that makes it alive. The still image only gains meaning through the flow that connects it. The same is true of your life. Each instant is defined not by what it contains, but by how it moves into the next. Time is not a collection of snapshots. It's the act of watching them flicker. If the universe ever truly stopped, if every atom, every force, every vibration ceased, the question of whether time remained would be unanswerable, because there would be no one left to ask. The very act of questioning requires change, and change requires time. It's a loop we can't step outside of. Perhaps that's the secret. Time isn't a backdrop to existence or a property of it. It's the awareness of difference, the pulse of transformation. Without it, even eternity would be empty. So maybe the question isn't whether time can exist without change, but whether anything can exist without it. The answer, whispered by the universe itself, seems to be no. The cosmos breathes through motion, and time is that breath. It's the expansion and contraction, the flicker and fade, the endless unfreezing of the moment. Even in the quietest corners of space, in the stillest depths of thought, something always stirs. A field trembles, a particle flickers, a thought forms. And with that trembling, time begins again. At the smallest scales imaginable, time begins to tremble. What seems steady and continuous in our everyday world, the smooth passing of seconds, the gentle unfolding of cause and effect, dissolves into something uncertain. Deep in the quantum realm, the universe doesn't tick like a perfect clock. It flickers, moments blur into probability, and what we call time might not be a steady flow at all, but a restless shimmer of possibilities, switching on and off faster than comprehension can follow. In quantum mechanics, nothing happens until it happens. A particle doesn't travel from point A to point B like a bead sliding on a wire. It exists in a cloud of maybes, a haze of potential locations and states, only choosing one when it's observed or disturbed. Between those moments of observation, what is the particle doing? The equations say it's everywhere and nowhere. It's in a superposition, an overlap of possibilities, and time for that particle is not the ticking of a second hand, but a pulse of uncertainty. Each instant might not follow neatly after the last. Instead, the universe could be flickering between outcomes, painting reality one probability at a time. Physicists once believed time was continuous, infinitely divisible, like a line that could be sliced forever without losing its shape. But at quantum scales, at distances near the Planck length and durations near the Planck time, continuity might break. The Planck time is unimaginably brief, about 10 to the power of -44 seconds. It is the smallest interval that can exist before the very concept of time stops making sense. Below that, our equations collapse. The idea of before and after loses its meaning. The universe may not flow smoothly at all. It might update itself in pulses, each tick a new frame in an invisible cosmic film. If reality does run on frames, the rate is inconceivably fast, so fast that everything we experience feels fluid. Just as a movie appears continuous when played at 24 frames per second, the universe at its deepest level might be rendering existence billions upon billions of times each second. Between each frame lies nothing, no motion, no change, no time at all. Only when the next frame appears does motion resume, and our consciousness stitches them together into a story that feels unbroken. We live inside that illusion, unaware of the gaps. But there's another view, one that's even stranger. Some physicists suggest time itself isn't fundamental, that it's not something the universe has, but something that emerges when things change relative to each other. In this picture, time is not a universal drumbeat, but a pattern woven from interactions. The ticking of a quantum clock doesn't measure time passing, it creates it. Each event, each quantum flicker, is both a cause and a definition of what time means in that tiny corner of the cosmos. Without those changes, there would be no difference between past and future. The clock would not stop, it would never have started. Even the act of measuring time becomes slippery down there. The more precisely you try to track an interval, the more uncertain the energy involved becomes, thanks to the Heisenberg uncertainty principle. Push far enough, and your attempt to pin down the moment actually distorts it. Time measurement and energy are entangled in a cosmic trade-off. The sharper one becomes, the blurrier the other gets. There's a limit to how finely the universe lets itself be observed, as if reality protects its own rhythm from being exposed completely. Quantum clocks, devices that use the oscillations of atoms to mark time with astonishing precision, are the closest we've come to listening to that rhythm. The best of them lose less than a second over the age of the universe. Yet even they reveal something unsettling. When measured against different gravitational fields or motion, their ticks diverge. Time itself stretches and squeezes, even at the smallest scales. It's not a single beat, but a choir of shifting tempos, each one shaped by where and how it's heard. The closer you look, the less it resembles a metronome, and the more it feels like a jazz improvisation, chaotic, local, alive. And so, in the quantum world, the future isn't fixed waiting to happen. It's a spectrum of possibilities trembling in superposition, waiting for an event, a measurement, a collision, a choice to collapse it into reality. Every flicker of time is a decision made by the universe, a branching of probabilities into one path. Perhaps that's why quantum physics feels so intertwined with consciousness. Observation doesn't just record what is, it helps determine what becomes. Every moment may be born from this interplay between what could be and what is noticed. What does it mean, then, to say the universe ticks? Maybe there is no cosmic clock at all, no fundamental rhythm underneath it all. Maybe time is the shimmer of existence itself, a side effect of change, a whisper between energy and matter as they negotiate what comes next. In that view, the flicker never stops because the universe never truly rests. Even the emptiest vacuum is alive with virtual particles flashing into being and disappearing again, each one a spark of possibility, each one adding another quiver to the trembling fabric of time. If you could somehow step outside of that flicker, you might find no flow at all, no past or future, only an endless quantum present, eternally vibrating with potential. But step back inside, and the movie begins again, each frame blending seamlessly into the next, too fast for your senses to catch. Time, as you know it, is the feeling of that flicker smoothing itself into something continuous. You are part of that illusion, living between frames, carried forward by a sequence so quick it feels eternal. Somewhere, beneath it all, the universe may be blinking on and off, moment to moment writing reality, in the flicker between nothing and everything. Time travel begins as a dream, a thought experiment whispered through science and myth alike. The wish to go back, to undo, to witness again. But in physics, it's more than fantasy. Buried within Einstein's equations are shapes of space-time so strange that they seem to twist the arrow of time into a loop. These aren't science fiction tricks or metaphors. They are real, mathematical possibilities, closed, time-like curves, paths through the universe that loop back on themselves, where tomorrow can reach out and touch yesterday. To understand how, you have to start with what Einstein taught us. Time and space are not separate. They're a single fabric that bends and stretches in response to matter and energy. Gravity isn't a force pulling things together. It's the geometry of space-time itself, curving around mass. That curvature guides everything, even light. If space-time can bend enough to form an orbit around a star, then in theory, it could bend enough to curve time back upon itself. A perfect loop in the cosmic fabric. A path that returns not just to a place, but to a moment. Such loops are called closed time-like curves, trajectories through space-time that allow an object to return to its own past. They appear in solutions to Einstein's field equations, though always in the company of strange, almost impossible conditions. One example is the Gödel universe, proposed by Kurt Gödel in 1949, a rotating cosmos where time loops exist naturally, allowing journeys backward through history. Another arises in the concept of a traversable wormhole, a tunnel connecting two regions of space-time, its ends synchronized differently in time. Step through, and you might emerge before you entered. The math allows it. The universe, perhaps, does not. But possibility is enough to trouble the mind. Because once you allow backward travel, the questions multiply. What happens to cause and effect when the effect can influence its own cause? What becomes of logic when an action can prevent its own existence? The grandfather paradox is the simplest form of this tension. If you go back in time and prevent your grandfather from meeting your grandmother, you would never be born. But then, who prevented the meeting? The loop collapses into contradiction, yet physics, strange as it is, offers ways out. One interpretation is self-consistency, the idea that the universe allows loops in time, but only those that remain internally consistent. You can travel back, but whatever you do, there will always lead to the same future you came from. You can't change history because your actions were already part of it. If you went back and saved someone from dying, it's only because you were meant to. You were always there. The timeline folds neatly, each cause feeding its own effect. This notion, called the Novikov self-consistency principle, suggests that paradoxes don't destroy logic, they close it. The universe, in its infinite precision, refuses contradictions. Every loop finds harmony with itself, like a melody returning to its beginning. Free will bends here, but does not vanish. You can make choices, but only those the timeline allows. It's not so much a cage as it is a pattern too vast to see from within. There's another interpretation, though, one that feels even stranger. Quantum physics suggests that every possibility, every branch of probability, exists in parallel. Perhaps traveling backward doesn't alter your own past. It creates a new one. Each change opens a new timeline, a separate thread spun from the same beginning. You can visit yesterday, but not your yesterday. The paradox dissolves because the universe keeps every version. Nothing is rewritten. Everything simply multiplies. Still, The question lingers, can such paths exist in reality? For a wormhole to function as a time machine, it must remain open, stable, against collapse. But according to our current understanding, that would require negative energy or exotic matter substances that may not exist in usable form. Even if they did, the moment a time machine became possible, the universe might protect itself. Stephen Hawking proposed the chronology protection conjecture, the idea that nature forbids time travel by destroying such loops the instant they form. Like a cosmic immune system, spacetime might recoil against paradox, and yet, in subtle ways, time already bends. Gravity slows it, speed stretches it, clocks diverge in orbit, in flight, in fields of immense mass. The difference is tiny, but it's real. The laws that govern these distortions don't draw a line between slowing time and reversing it. They simply require more energy, more curvature, more strangeness than the universe may be willing to permit. Time travel is not forbidden by the math. It's forbidden by the practicality of existence. But the thought won't die, because time, for all its forward flow, remains flexible in theory. Every equation describing motion can be reversed. Every physical law, apart from entropy, is symmetric in time. The past and future are twins, their separation enforced only by the way we experience them. Perhaps time travel is less about machines and tunnels, and more about understanding that the universe itself may not prefer one direction over another. The arrow we feel could simply be the path of least resistance, the slope of entropy guiding us down a hill we cannot climb. Still, it's haunting to imagine a loop in that slope, a fold so deep that yesterday lies just beyond the horizon of tomorrow. Maybe, somewhere in the universe's vast geometry, such loops already exist, closed upon themselves, isolated from causality, humming in silence. A region where time circles endlessly, where events repeat forever, where a particle or a person could meet themselves across the curve of eternity. We may never build a machine to step into those loops, but the idea alone reveals something profound. Time is not rigid. It's not a line etched in stone. It's a fabric capable of folding, twisting, returning. And in that folding lies both the possibility and the warning. That to master time is not just to travel through it, but to become part of its infinite recursion, forever chasing the tail of your own becoming. You live inside a story your brain is constantly rewriting. Every moment you think you're experiencing the present, but what you're really sensing is already past reconstruction, delayed and smoothed out by the machinery of your own mind. Light reaches your eyes, sound vibrates your eardrums, nerves fire, signals crawl through tissue, and your brain collects it all, polishes it, and presents it as now. That now feels seamless, immediate, unquestionable. But it's an illusion, an elegant hallucination the mind performs to make sense of a universe where true simultaneity doesn't exist. The human brain is not a camera capturing frames of reality in real time. It's a prediction engine. It anticipates what's about to happen based on what just happened and fills in the blanks before the next signal arrives. The delay is tiny fractions of a second, but it's enough that you never experience the world as it is, only as it was. Every sight, every sound, every heartbeat is a memory dressed up as a moment. The present is always history pretending to be current. Your brain compensates by synchronizing its delays. Vision, hearing, and touch don't travel at the same speed, yet your mind aligns them perfectly so the world doesn't seem out of sync. When you watch lightning strike and then hear thunder, you notice the lag. But when you watch someone speak, you don't. The brain quietly edits the footage, stretching and compressing perception until cause and effect seem to unfold naturally. It creates a coherent timeline from a messy flood of asynchronous data. You don't notice the editing because noticing it would break the spell. Consciousness, in this sense, is a kind of biological relativity experiment. Each neuron, each sensory channel, processes its signals at its own pace, depending on distance, pathway, and context. The brain acts as a central observer, reconciling these local times into a shared narrative. Just as Einstein showed that simultaneity depends on perspective, your mind proves it every second. There is no single now within you, only overlapping frames of reference stitched together to feel continuous. The illusion of unity is the price of coherence. It's strange to think that your sense of time, of flow, of progression, of self moving forward isn't a property of the universe at all, but of your brain's architecture. Different parts of the brain experience time differently. The visual cortex processes motion. The cerebellum measures intervals. The prefrontal regions weave it into meaning. Each system has its own tempo, yet together they produce the feeling of one smooth river. The brain isn't swimming in time, it's building it from the inside out. You can glimpse the cracks in the illusion when that synchronization falters. Under stress, time seems to slow. During joy, it flies. In danger, milliseconds stretch into seconds, as if your mind were sampling more frames to catch every detail. Drugs, trauma, meditation, all can warp the brain's temporal rhythm, bending perception without touching the external world. What changes isn't time itself, but your internal relativity, the calibration of your mental clock. The universe doesn't speed up or slow down. You do. Memory deepens the illusion. You don't just experience now, you construct it based on what you've stored. Each new perception passes through the filter of memory, shaped by expectation and habit. The brain predicts, remembers, and revises all at once, turning the flow of information into a movie of continuity. You feel like a traveler moving through time, but really, you're the projector, playing a film so smoothly that the flicker disappears. Consciousness is the light beam that makes the story visible, even though the story was already written a few milliseconds before. Some neuroscientists suspect that what we call the present, the tiny window of experience we identify as this moment, spans only a few tenths of a second. Everything outside it feels like past or future. But that window slides constantly, never fixed, always refreshed. It's like living in the overlap of memory and anticipation. The world feels stable because your brain keeps predicting it faster than it changes. Every blink, every thought, is a small act of timekeeping. You are not merely aware, you are timing your own awareness. If you could somehow step outside that process and see your brain's inner workings in motion, the illusion of the present would dissolve instantly. You would see a network of neurons flashing at different rates, none of them experiencing the same instant. There would be no unified you, no singular now, only a constellation of electrical storms weaving fragments into meaning. The coherence of consciousness is like the coherence of a galaxy. Millions of stars bound by gravity, each moving independently, yet appearing as one. Perhaps that's why consciousness feels so fragile, why the self seems to flicker at the edges. It's not built to perceive the raw universe, only to survive within it. The sense of now, the feeling of flow, the conviction that time is moving. These are shortcuts, evolutionary tricks that make coordination and decision possible. To see the world without that illusion would be unbearable. You would exist in a blur of probabilities, where past and present bleed together, where cause and effect lose their order. The brain hides that chaos beneath the comforting fiction of the moment. Still, there's something beautiful in the deception. The fact that your mind must bend physics to make experience coherent says something profound about being alive. You are a creature who cannot know time as it is, only as it feels, and yet, within that limitation, you find meaning, memory, anticipation, love. Consciousness is a relativity experiment that never ends, an observer caught in its own creation, forever chasing the horizon of now. And somewhere in that chase, in the gap between what is and what you believe is happening, you find yourself, flickering and real, suspended in the illusion that makes reality bearable. There are places in the universe where time no longer makes sense. Not because it moves too slowly or too fast, but because it ceases to exist in any form we can recognize. Deep inside a black hole, past the event horizon where even light cannot return, lies a singularity, a point where the laws that govern everything else fall apart. The mathematics that describe space, energy, and motion collapse into infinities. Density becomes immeasurable, curvature becomes absolute, and time, the quiet current carrying every moment forward, simply ends. It's hard to picture what that means, because the human mind has never experienced the absence of time. We can imagine it speeding up, stretching, looping, even reversing but not disappearing. Time is the stage for every thought we've ever had. It's the invisible backdrop against which everything happens. To lose it entirely is not to face stillness. It's to face something that exists outside of happening. Inside a singularity, there is no before or after, no cause or consequence. The universe there is stripped of sequence. Existence itself becomes a question without a tense. At the center of a black hole, general relativity, the theory that has predicted every cosmic curve and orbit with breathtaking precision, reaches its breaking point. It tells us gravity grows infinite and space-time folds into itself. But infinity is not a number, and physics cannot calculate beyond it. That's the boundary of understanding, a wall where every equation fails. It's as though nature hides its most intimate truth behind an event that no observer can witness. What lies beyond the horizon is not just invisible, it's unknowable. Einstein's theory paints the broad strokes. Matter tells space how to curve, and space tells matter how to move. But when enough mass is crushed into too small a space, the curvature becomes so extreme that the rules reverse themselves. Space falls inward, time tips over. The very directions of forward and backward lose their meaning. For an object crossing that line, there is no path out, only deeper. Time doesn't carry it onward. It drags it toward an inevitable end, a singular future that can never be escaped. Yet for the outside observer, the fall never completes. To someone watching from afar, the infalling object slows as it nears the event horizon. Its clock appears to run slower and slower until it freezes entirely, forever suspended at the edge. From the outside, nothing ever truly crosses into the black hole. The moment of crossing stretches into eternity, but from the falling object's own point of view, everything happens quickly. It plunges inward and reaches the singularity in what feels like seconds. Two perspectives, equally valid, yet eternally divided by space-time's distortion. And then there's the deeper mystery. What happens when the universe's own clock stops ticking? If the singularity represents an end to time, is it also the beginning of something new? Some physicists think of black holes not as endings, but as transitions. When matter collapses beyond the horizon, perhaps it doesn't vanish, it passes through. The singularity could be a bridge, a throat leading to another region of space-time. In that case, a black hole might not be a grave but a seed, its interior blossoming into a new universe with its own time, its own arrow, its own expansion. It's a comforting idea that endings might double as beginnings, but it's also deeply humbling, because even if that's true, we can never follow to see it. From our universe's perspective, the singularity remains sealed away, its timeline disconnected from ours. The death of time is a private event, witnessed by nothing that can return to tell the story. We are left only with the boundary, the equations trembling at the edge of meaning, and the faint radiation that leaks outward as black holes slowly evaporate. Even in that decay, there's irony, the end of time itself taking time to end. Quantum mechanics, our other great theory, refuses to accept the silence. It says information cannot be destroyed. Every particle, every bit of energy that falls in must leave some trace, even if we don't know how. To reconcile this, physicists imagine time and space as something granular and finite, a mesh of quantum fabric that doesn't tear but folds. At the Planck scale, perhaps the singularity isn't a point at all, but a region where the fabric knots in on itself, preventing true infinity. In that picture, time doesn't end, it fractures, curls, transforms. The breakdown of one kind of time may give birth to another, and yet, the question lingers, vast and unsatisfied. What does it feel like when time ends? We can't simulate it. We can't test it. All we can do is stand at the edge of what we know and stare into the mathematics that fail us, trying to read meaning in their silence. Maybe the singularity isn't a flaw or a gap. Maybe it's the universe's way of reminding us that we were never meant to see all of it, that existence itself has horizons. If time truly dies inside a black hole, then somewhere in the cosmos, endings already exist outside of time's reach. And if that's true, perhaps the same is true of beginnings. Maybe every birth, every creation, every unfolding moment carries within it a quiet echo of that collapse. Maybe we're all built from the residue of broken time, still moving forward only because somewhere, deep down, the universe remembers how to stop. And perhaps that's where it all began, not in light, but in the silence that came before time knew how to move. When you look at the night sky, what you're seeing isn't motion through space, it's the stretching of space itself. The galaxies drifting away from us aren't flying like sparks from a fire. They're passengers on an expanding fabric, carried by the growth of the universe itself. It's not that they're moving through space, it's that space between everything is increasing. Every beam of light, every cosmic structure, every second that passes does so on a stage that is constantly swelling, and with that expansion, time changes too. Because in the universe, space and time aren't separate, they're the same fabric, and when one stretches, the other bends. In the early moments after the Big Bang, the universe was impossibly small, hot, and dense. Every particle and photon was packed so tightly that space and time barely existed in any familiar sense. Then, almost instantly, expansion began, not an explosion, but a rapid unfurling. Space itself swelled, carrying everything outward. As it expanded, the temperature dropped, the first atoms formed, and the universe began to cool and slow. The rhythm of time, which in that fiery beginning beat almost too quickly to measure, softened into something steadier. Expansion didn't just separate galaxies, it set the tempo for the cosmic clock. You can think of this clock as universal, but it doesn't tick the same everywhere. To a cosmologist, cosmic time is the time measured by observers who move with the expansion of the universe, those who see the cosmos as homogeneous on the largest scales. To such observers, the universe has an age, a shared history, a kind of synchronized heartbeat that began with the Big Bang and continues now, roughly 13.8 billion years later. But that's an idealized view. Locally, time dances to its own tune. In galaxies bound by gravity, in black holes, on planets like ours, space resists expansion. Gravity anchors it. And wherever gravity grows strong, time slows. As the universe expands, the wavelengths of light stretching across it grow longer too. Photons that began as blue, high-energy waves from young galaxies are redshifted as space swells between them and us. The light loses energy, not because it's colliding with anything, but because the very metric of distance, the ruler of space-time, has changed. The universe's expansion stretches not just light, but time itself. Each oscillation of a wave takes longer. Each cosmic pulse beats slower. What we see when we look at the most distant galaxies isn't just distance. It's ancient light, arriving through the slow drag of cosmic expansion, bearing the mark of time's own dilation. In the farthest reaches of the observable universe, we see galaxies receding faster than light. It sounds impossible, but relativity allows it, because they aren't moving through space, they're moving with it. Space itself expands so quickly that light emitted from those galaxies may never reach us. The horizon of the visible universe is not a wall, but a limit, a boundary defined by how far light can travel through the ever-stretching medium of space-time. Beyond that, time continues, but not for us. It's a reminder that cosmic time, like everything else in relativity, is local, dependent on where and how you measure it. There is no single cosmic present stretching across the entire universe. There is only what each observer can see, bounded by the light that's had time to arrive. And this expansion isn't slowing down, it's accelerating. Distant galaxies are being carried away faster than they once were, driven by a mysterious force we call dark energy. No one knows what it is, only that it makes up nearly 70% of the universe and acts like a pressure built into the vacuum of space. Its effect isn't just to push galaxies apart, but to change the future rhythm of time itself. As space continues to stretch, the gaps between galaxy clusters will widen until they drift beyond each other's light. Someday, long after our sun has faded, the night sky will grow empty. The great cosmic web of galaxies will retreat beyond visibility, leaving each island of matter surrounded by darkness, cut off from the rest of the cosmos. In that far future, time will continue to flow, but meaningfully only within small, gravitationally bound regions. Each galaxy will be its own lonely universe, its stars dimming, its clocks ticking in isolation. The background glow of the Big Bang, the faint microwave radiation that still fills all of space, will fade beyond detection, stretched until its wavelength is longer than the universe itself. Even light will lose its identity in the silence of expansion. The universe won't end in fire or collapse, but in emptiness, a slow unraveling of connection, where time drifts on but has nothing left to change. And yet, even that melancholy image hides a strange kind of beauty, because the expansion that isolates us is also the reason we exist. Without it, matter would never have cooled, stars would never have formed, and the clockwork of time would have remained too fast, too hot, too brief to allow life. The stretching of space gave the universe room to breathe. It allowed time to slow enough for complexity to bloom. Every second you experience is part of that deceleration, the lingering echo of the cosmos expanding around you. So when you look into the night sky and see galaxies receding, remember they're not leaving you. The space between you and them is simply growing, and with it, the rhythm of time itself. Every distant light you see is an old song, stretched thin by the universe's breath, still singing its way across the widening dark. The cosmos is expanding, and so is time, an endless unfolding of seconds written into the fabric of everything, each one a little longer, a little softer than the last. The universe, as we know it, seems to prefer direction. Eggs break, but don't unbreak. Stars burn, but don't reignite. Memories flow one way. Time has an arrow, and everything we know follows it. But deep in the equations that govern matter and motion, the arrow disappears. The fundamental laws of physics, whether describing gravity, electromagnetism, or quantum particles, work perfectly well in reverse. If you filmed the universe and played it backward, the math would not complain. A planet could orbit in reverse, a collision could unhappen, and every law would remain intact. The only thing that resists this symmetry is us, the macroscopic world, built from entropy, from disorder increasing, from history moving in one direction. Time seems to have a preferred way to flow, but what if, somewhere else, it flows the other way? Physicists call this time symmetry, and it's one of the strangest puzzles in cosmology. If the laws of nature don't demand that time run forward, why does it? The best answer we have points back to the beginning, the universe's low entropy birth, when everything was unnaturally ordered. From that improbable starting point, chaos spread outward, creating stars, galaxies, and eventually consciousness, all moving along the gradient of increasing entropy. But if the universe could start that way, perfectly balanced and highly organized, Could another universe have started in the mirror image, a cosmos where time's arrow points the opposite direction, where our future is their past? It sounds like fantasy, but the equations of cosmology allow it. If the Big Bang created not one universe but two, they might be reflections of each other, expanding away in opposite temporal directions. To us, they would look reversed, their time flowing backward relative to ours. But to their inhabitants, life would feel normal. Their stars would still ignite. Their hearts would still beat forward in their version of time. It's only from outside, if such a view were possible, that the symmetry would be visible. Two universes, born from the same event, diverging not just in space, but in time itself. This idea isn't pure speculation. Some physicists, like Sean Carroll and Julian Barbour, have explored models where time's arrow emerges locally, not globally. In these models, the Big Bang isn't the beginning of time, but the midpoint, a central boundary between two regions of spacetime, expanding in opposite temporal directions. In both halves, entropy increases away from the center. To us, it seems we're moving forward from the Big Bang. To them, they're doing the same, but in the reverse direction. Each side experiences its own thermodynamic arrow, its own unfolding of history. Both are right, both are mirrors. It's almost impossible to imagine what that means for cause and effect. In such a mirror universe, what we call the end of time might look like their beginning. A dying star here could correspond, in some mirrored sense, to a forming star there. Perhaps even the collapse of one universe's black holes could seed the birth of matter in the other. Energy flowing in one direction would flow oppositely in the other, yet each would experience it as forward. It challenges everything we mean by direction. And then there's the quantum realm, where time loses its familiar meaning entirely. At that scale, the universe doesn't evolve smoothly from one state to another. It exists as a superposition of possibilities, a blur of maybes that only resolve when observed. Quantum mechanics doesn't care about time's arrow. The equations that describe how particles behave are symmetric. They work equally well, backward or forward. The apparent flow of time may only emerge once probabilities collapse, once observation gives events an order. Before that, the universe is timeless, a cloud of potential waiting for someone to define sequence. If that's true, then perhaps time itself isn't a property of the universe, but of perspective. The arrow might be a trick of scale, an illusion born of entropy and awareness. On the grand level of equations, there's symmetry. On the local level of existence, there's direction. We feel time because we are made of things that change irreversibly. Our memories point one way. Our bodies age. Our stars burn. But beyond that veil, in the quiet world of quantum mechanics or the possible realm of mirror universes, there may be no forward or backward, only structure and counterstructure, reflection and balance. Some imagine a multiverse, a vast ensemble of realities, each with its own constants, laws, and histories. In such a landscape, there could be universes like ours and others running in reverse. There could be countless timelines, some frozen, some branching, some looping endlessly. Time, in that greater whole, might be nothing more than a coordinate, one dimension among many, free to vary from world to world. Somewhere, perhaps, a version of you is walking backward into what you'd call the past, remembering the days still waiting ahead. To them, it feels ordinary. To us, it feels impossible. Yet even in its impossibility, there's a strange comfort. The symmetry suggests that time's arrow, with all its heartache and inevitability, isn't fundamental. It's just one way the universe can be. Somewhere beyond our horizon, there may be balance, another side of the coin, where loss is gain, decay is creation, and endings are beginnings reversed. Perhaps the cosmos itself is that symmetry, one universe flowing forward, one backward, forever expanding into each other's futures. And maybe that's why the universe feels incomplete from where we stand. We sense time's passing not as a flaw, but as half of something larger. Our arrow points one way, but the equations whisper that it doesn't have to. Somewhere, in the mirrored dark, time might be unwinding, its story running backward through a reflection of everything we know, the two halves together, forming not contradiction, but completion, the universe remembering itself from both ends of eternity. There will come a day when everything stops happening, not suddenly, not with an explosion or a final flicker, but with a long, slow, fading so slow it will feel like eternity, exhaling its last breath. The stars will die first, one by one, their fuel spent, their warmth gone. Galaxies will grow dark, their spiral arms dissolving into the cold drift of intergalactic night. The last red embers of starlight will fade, leaving only black holes and dust scattered across the vast emptiness. And even then, time will still move. But without change, without motion, without heat or life or memory. What will that movement mean? When nothing happens anymore, does time still exist? This is the fate physicists call the heat death of the universe, the final equilibrium of all things. It's not a violent end, but a quiet surrender. Entropy, the measure of disorder, always increases. It's the law that governs the arrow of time, the reason eggs break and stars burn, the reason we grow old instead of young. The universe has been running downhill since the Big Bang, energy spreading thinner, gradients flattening, differences dissolving. One day, all usable energy will be gone, every potential smoothed out, every contrast erased. In that perfect uniformity, there will be no direction left for time to point. The clock will keep ticking, but nothing will mark its passing. Even now, in our vibrant age of galaxies and light, the seeds of that stillness are everywhere. Every time a star shines, it hastens the approach. Every photon streaming into space is energy lost forever to the background sea. The universe expands, and with expansion comes cooling. The cosmic microwave background, once the roar of creation, has already faded to a whisper barely above absolute zero. It will keep fading, stretching thinner as the cosmos grows. What began as fire will end in frost. In a few trillion years, the last generation of stars will flicker out. Their ashes will scatter into the void, and darkness will settle across the galaxies. The night sky, once jeweled with light, will become a colossal graveyard of invisible remnants, white dwarfs, neutron stars, and black holes drifting in silence. Planets will freeze, atmospheres collapse, atoms slow. The universe will enter what physicists call the degenerate era, when matter itself has nothing left to do but wait. And still, time will pass. Trillions of years later, black holes will begin to evaporate through Hawking radiation, leaking their mass back into the void as faint whispers of energy. Slowly, patiently, they too will disappear, until the last black hole fades in a burst too weak for any witness. After that, there will be only radiation, thin, cold, and uniform, spreading across an immeasurable emptiness. No gravity to clump it, no stars to shine, no motion to mark difference. The universe will have reached thermodynamic equilibrium. It will be, in every sense, the end of history. But this end is stranger than it sounds, because time as we understand it depends on change. We feel its passage through events, through entropy increasing. If the universe becomes static, no gradients, no energy left to move from one place to another, then time loses its function. Seconds may still exist mathematically, but they would have no story to tell. Without difference, every moment is identical to the next. The river of time freezes not because it stops flowing, but because the water has become perfectly still. It's unsettling to imagine a cosmos that continues without purpose, where every trace of structure has dissolved, where even decay has decayed. Yet, in that silence lies a peculiar kind of beauty. The heat death isn't destruction, it's balance. Every particle evenly spaced, every energy evenly shared, every motion resolved. The universe, for all its chaos and violence, will have finally reached peace. It's not a peace we could survive or even comprehend, but it's the final symmetry of everything that ever was. Some scientists whisper that perhaps this isn't truly an ending. Quantum mechanics, in its restless uncertainty, might not allow perfect stillness. Tiny fluctuations could still ripple through the void, random and rare. And given enough time, so much time that numbers lose meaning, those fluctuations could spark something new. A pocket of low entropy, a spark of imbalance, a seed for another beginning. From the stillness, expansion might bloom again, another universe unfolding from the ashes of the last. Perhaps this has happened before, countless times. Perhaps every death of time gives birth to its next version. But if this universe truly fades to nothing, if it cools beyond all motion and no spark ever returns, then its story will end, not with a bang, not even with a whisper, but with silence so perfect it erases the very concept of before and after. In that eternal quiet, the distinction between past and future will vanish. All that was and all that could be will merge into a single, frozen moment that stretches forever. And maybe, in that frozen stillness, there will linger a kind of ghost of energy, of order, of memory, the echo of what once burned bright. Because time, even when broken, leaves traces. Its story is written not in clocks or equations, but in the universe's memory of having been alive. The heat death of time is not the death of meaning. It's the moment when meaning becomes eternal, fixed forever in the faint afterglow of everything that ever happened, waiting quietly in the dark. You are not standing outside of time, peering in. You are not a passenger being carried along a current that flows without you. You are the current. Every moment you have ever lived, every heartbeat, every flicker of thought has been time moving through you, or perhaps more truthfully, time becoming you. The seconds you count are not beads on a string. They are the texture of your own existence. You are not separate from time. You are time gathered, embodied, aware for an instant. Think of everything that has had to happen for you to sit here, breathing, reading, wondering. The atoms in your body were forged in stars that lived and died billions of years ago. The calcium in your bones, the iron in your blood, the carbon lacing your cells, all of it drifted through the void long before Earth had oceans or sky. Those atoms cooled with the expanding universe, gathered into clouds, collapsed into suns, and then into planets. They endured the long, slow ticking of cosmic time and eventually assembled into a pattern capable of noticing itself. In you, time remembers its own history. Your heartbeat is not just a pulse of blood, but a rhythm echoing the first rhythm, the expansion of space itself. Your breathing is a tide shaped by tides before it, by the rising and falling of stars, by the laws of motion and decay, by the arrow of entropy guiding everything forward. You are a local pattern in the great unfolding, a place where the universe has briefly arranged itself to look out at its own vastness and wonder. When you think of the past, it is not a distant thing you're reaching for. It's the universe thinking about its own earlier shape. When you imagine the future, you are time rehearsing its next act. We often speak as though we move through time, as though it is something external, a road we travel. But that's only the story our minds tell to make sense of change. In truth, time doesn't move. Time is the stage, and the actor, and the witness, all at once. And you, with your memories and anticipations, are one of its expressions, just as a wave is the expression of the sea. When you feel the passing of a moment, it isn't something being taken from you. It's you unfolding, second by second, into what you already are. This means you are not simply in the present. You are the present. The light hitting your eyes is old. The neurons firing in your brain are delayed, and yet somehow it all converges here, in this sliver of awareness. That convergence is not trivial. It is extraordinary. Out of all the countless arrangements of matter and energy the universe has tried, it has made one capable of experiencing now. Your awareness is a window cut into the fabric of time, a way for the cosmos to glimpse itself not as equations or forces, but as feeling. And in that glimpse, something tender happens. Time, which on its largest scales is indifferent and unstoppable, softens into intimacy. It becomes the warmth of a memory, the anticipation of a touch, the pause before a word. It becomes the story you tell yourself, the life you build, the meaning you give to the passing seconds. This intimacy isn't separate from the cosmic vastness it's made of it. The same laws that govern galaxies govern the beating of your heart. The same expansion that cools the void makes space for your thoughts. One day, the atoms that make you will drift apart again. The rhythm of your heartbeat will stop, and time will go on in other forms. But that doesn't diminish what you are right now. In this moment, you are the universe awake, experiencing itself at a scale small enough to love, to fear, to wonder. This is not an accident. This is time's own unfolding, reaching a point where it can look inward and recognize its reflection. To realize this is not to lose yourself, but to see yourself more clearly. You are not a small creature trapped in time's current. You are the current taking shape as a creature. You are the memory of stars held in skin. You are a pattern of seconds holding hands, making a self for a while. The universe is vast beyond comprehension, but here it is, condensed into a single awareness, the one reading these words, the one breathing, the one who feels. You, here, now. The universe remembering itself for a moment. The rhythm of time gathered into a heartbeat. The endless story pausing briefly to say, I am. And then, like everything else, moving on, yet never lost, because every instant is still folded into the fabric of what is, waiting quietly in the dark as time itself, through you, learns how to be conscious.